Hello everyone, welcome to this video. In this video, we'll be solving this question which states that D4 has 7 cyclic subgroups. So they have already stated that the dihedral group D4 has 7 cyclic subgroups. We just have to tell which all of them are. Correct? We have to list them. So we already know D4 has 8 elements within it, right? These all. And the Kelly table for D4, it is also given to us. We saw it multiple times. Now we have to see which is the generator here which create these cyclic groups, right? And in fact, what different generators can we have? So if you take the powers of R0, you are only going to get R0 from it. So you know this singleton set consisting only of the identity element is a subgroup. And why it is a and moreover it is a cyclic subgroup. Why? Because it could be written as powers of R0. Hence this forms one of our cyclic subgroups. Next, let's take the second element as R90 and let's raise it to different powers. So when you raise it to different powers, you see R90 raised to power 1 is just R90, R90 raised to power 2. So when you compose R90 with R90, you get R180. So you get the second element. When you raise R90 to the power 3, so basically what you are doing, you are performing R90 square into R90. What is R90 square? R90 square is R180. R180 into R90. R180 is here, R90 is here, so the answer is R270. So you have R270. And when you raise it to power 4, so power 4 could be breakdown into power 2 into power 2, right? Power 2 is what? It is R180. So it is R180 into R180. R180 is here, R180 is here. So the answer is R0. So the fourth element is R0. Next, when you raise it to power 5, so what would happen? Let's see. When you raise it to the power 5, so basically what you are doing, you can write it like this: R90 raised to power 4 into R90. What is R90 raised to power 4? It is R0, correct? So R0 into R90, what is it? It is R90. So you see, you start getting the elements which are repeating themselves. So therefore we stop our group here, no new elements would be present. Hence the subgroup which is generated by the element R90 is that contain 4 elements within it: R0, R180, R90 and R270, right? So this is the second subgroup, cyclic subgroup in fact, which we obtained from R90 by taking the powers of R90. Right? What about the third element? If we now consider the third element R180, when you raise it to different powers, let's see what do we have. R180 raised to power 1 is just R180. What is R180 raised to power 2? R180 into R180 is R0, right? So it is R0. When you raise R180 raised to power 3, so basically what you are doing R180 raised to power 2 into R180. R180 raised to power 2 is what? R0. R0 into R180 is what? It is R180. So the answer here is again 180. And when you take it to the power 4, you see the answer would be R0. So the different powers of R180 would just give you these two elements oscillating one and again. Once you get one R180, the other time you get R0. So the third cyclic subgroup that we obtain from here is R180. The one which is generated from R180, it contains only 2 elements within it. Okay. Now let's take the fourth element here, R270. So you see, when you take R270 and take its different powers, you just get back these 4 elements again and again. And this is what? This is exactly equal to the elements that you obtained when you take the generating element as R90. Hence this is nothing but the subgroup which is generated by R90. So you see, the subgroup which is generated by R90 is exactly the same as that generated by R270. Hence we will not take this case because it would just be a repetition of the one subgroup which we have obtained earlier, correct? Okay, what about the subgroup which is generated by H? So let's take different powers of H. H raised to power 1 is just H. h raised to power 2. Let's have a look. H is here, h is here. H raised to power 2 would give you R0, which is the identity element. So what about h raised to power 3? So h raised to power 3 is h square into h. H square is R0. R0 into h is what? It is again h. So you see, we start obtaining the elements which repeat themselves. So in this case, we only have two elements. One is h, another one is R0. Correct? So this is the next cyclic subgroup, the fourth cyclic subgroup that we obtain from here, right, from the elements of D4. What about the next one? If you take similarly the subgroup which is generated by V, D and D dash and take their different powers, in each of the cases you would get a subgroup which contains only two elements. First one contains V and R0, second one contains D and R0, and third one contains D dash and R0. Hence we have the 7 cyclic subgroups of D4 as the one generated by R0, the one generated by R90, the one generated by R180, the one generated by H, the one generated by V, the one generated by D, and the one generated by D dash. So this is our answer. So I hope you understood this question well. Well, that is it for this video. Thank you for watching.